Hey everybody, this is Mrs. Fry bringing you today's daily math video. I just want to give a shout out to Miss Taylor for telling me how to hook up the screen recording to my iPad so I can just video me writing on my iPad. I don't have to try to set my phone up to a tripod and get that centered over top of my iPad. So this is just going to look a lot nicer and I think be a lot easier for you guys to follow. So today's lesson, we're just going to do some more problems on synthetic division. I really love using this shortcut method for dividing a polynomial by a binomial. I think it's a lot of fun because you're just dealing with the raw numbers. So what you're going to do is you're going to take out the x's and we're just going to be looking at the numbers. The first thing I'm going to look at is what I'm dividing by, x minus 3. And I'm going to set that equal to 0. Okay, x minus 3 equals 0. And I'm going to solve that, adding 3 to both sides. And that is going to be x equals 3. And that's what we're going to use when we're dividing. When you set up your synthetic division problem, we will put the 3 on the outside, and then lined up across the top, that's where we'll put just the numbers, 10, negative 22, negative 17, and negative 21. And I like to put this little box down here below. Now we just start out by dropping down the 10, and then on the outside of the box, that's where you're going to multiply, and on the inside of the box, that's where you add. So when I multiply 3 times 10, that's 30, and I write that underneath of the negative 22, and then add negative 22 plus 30, and that's 8. Then multiply on the outside. 3 times 8 is 24, and that gets written underneath of the negative 17. And then negative 17 plus 24 is 7. So I write that underneath. Then the last step is to multiply 3 times 7, which is 21. And then finally we'll add those two together. Negative 21 plus 21 is 0. So this problem, I do not have a remainder because I end up with 0 in that box at the very end. So now I just need to put the x's back in to write my final answer. And you would want to write this as 1 less than what we started with. So because I started with an x to the third, that means for my answer, I would start with x to the second. So 10x squared, and then we just put it in descending order. So the next would be 8x, and then plus 7. And I don't have a remainder, so don't worry about that 0. So that's my answer, 10x squared plus 8x plus 7. Okay, now let's do another problem in which I do have a remainder. So for this problem, we'll start out the same way. Take what you're dividing by, x minus 4, and set that equal to 0. Then we're just going to solve for x. Add 4 to both sides. So that would be x equals 4. And that's what you're going to put on the outside of your synthetic division box. We'll put a 4 on the outside. And then across the top, on the inside of the box, that's where you're going to put the coefficients. So there's an invisible 1 here. So I'll put 1, and then negative 5, negative 3, and 26. So now I'll just drop down this 1, and then remember the pattern you're going to follow is multiplying on the outside and then adding on the inside. So I'm going to multiply 4 times 1, and I'll place the 4 underneath the negative 5. Then you'll add negative 5 plus 4, so that's negative 1. Then multiply again. 4 times negative 1 would be negative 4. And then add negative 3 times negative 4 is negative 7. Then multiply. 4 times negative 7 is negative 28. And then add 26 plus negative 28 is negative 2. Now to write my answer, I'm going to just put the variables back in. So because I started with x to the third, this would go down to 1x squared. So that's just x squared minus x minus 7. And then I'll put plus negative 2 over x minus 4. Okay, you take what you're dividing by and you set that up as your remainder. Okay then? So now let's try a little bit more difficult problem. Okay, so let's take a look at 4x to the third minus 8x squared minus x plus 5 divided by 2x minus 1. We'll start out the problem the same way. We'll take what we're dividing by, 2x minus 1, and set that equal to 0. So now you can see why this one's a little bit different. When I solve for x, I'm just going to add 1 to both sides and end up with 2x equals 1. Then divide both sides by 2, and I have x equals 1/2. So guess what? I'm going to have a fraction on the outside of my synthetic division bar. And then you're just going to line up your coefficients across the top. 4, -8, -1, and 5. Okay, now I'm just going to drop down this 4. And this is what could be kind of scary for some of you guys, but it's actually not that bad. When you multiply 1/2 times 4, that's just like taking half of 4. Everybody knows half of 4 is 2. So that's 2. Then we would add -8 times 2 is -6. And then again, we're going to multiply this fraction, 1/2 times -6. So just in your head, think, what's half of 6? It's 3, but because it's negative, we'll put -3. Then add -1 plus -3, that's -4. Oops. And then half of -4 would be -2. And then finally add 5 plus -2. You guys know that's just 5 minus 2, so that's 3. Now let's put our variables back into our problem, starting with an x squared, because it's always going to be 1 less than what we had in our original problem. So it's 4x squared minus 6x minus 4 plus 3 over 2x minus 1. That is your final answer. Okay, last example. This last example, I did have this one down here. I'm going to erase that. Okay, this last example starts with an x to the 6th. So we're going to have a lot of numbers here, but I'm going to need some placeholders. I have x to the 6th plus 4x to the 5th minus 2x to the 3rd plus 7. What happened to our x to the 4th, our x squared, and our x? Well, there isn't one, which tells me that's 0. So I'm going to need a lot of placeholders. So I would put 1 and then a 4, and then because I don't have an x to the 4th, I'll put a 0. And then I do have an x to the 3rd, so that's -2. I don't have an x squared or an x, so that's 2 more zeros, 0, 0, and then a 7. Okay, so now I need to take the x plus 1, set that equal to 0, subtract 1 from both sides, so I end up with x equals -1. Okay, that goes on the outside of your synthetic division bar. This is a really good example of what to do whenever you need to use placeholders. We're just going to put zeros there. Everything else is going to be exactly the same. We're going to drop down this 1. We're going to multiply by what's on the outside, and then add what's on the inside. So I've got -1 times 1, which is -1. Then we'll add 4 plus -1, which is 3. Then multiply. -1 times 3 is -3. Then we're going to add 0 plus -3 is -3. -1 times -3 is 3, and then add -2 plus 3, that's just 1. -1 times 1 is -1, then we add 0 plus -1, that's -1. -1 times -1 is +1, 0 plus 1 is 1, and then finally -1 times 1 is -1, 7 minus 1 is 6. 6 is the remainder. Now to write my answer, I'm going to go back to the beginning, and I see our problem starts out with x to the 6th, which means in my answer, I'll start out with an x to the 5th. So this would be 1x to the 5th, and then we just go in descending order, which means the next one would be plus 3x to the 4th, minus 3x to the 3rd, plus x squared, minus x, plus 1, plus 6 over x plus 1. That's a giant answer for a really big problem. I mean, we did start out with an x to the 6th, so that does make sense. Okay, so now let's take a look at your homework for today. Your homework for today is to check in with me on Remind. I just want to hear back from you guys that you're doing okay, like, hey, I'm doing great, or hey, I need some help with some of these problems, because I feel like a lot of you guys have been getting the videos, you've been watching them, but I haven't been getting anything back from you, and I'd like some feedback. So if you could just check in with me on Remind today for your homework, that would be great. And I hope you have a great day. Enjoy the sunshine. Bye.